For the final presentation of the day, we have another David. Please welcome David Hamdorf, GSWA Senior Geologist in Mineral Resources. David is part of our land use planning team, but has been doing some work with the New Energy Systems branch on characterising mine waste.
Kaya, good afternoon and hello. Today I'm talking about how pre-competitive geoscience can support a circular economy for mine wastes and tailings in Western Australia. I would like to respectfully acknowledge the traditional custodians of the land on which we meet today, the Wadjuk people of the Noongar Nation, and pay my respects to their elders, past, present and emerging. And respectfully acknowledge the traditional custodians across the length and breadth of the land where we conduct our geological mapping and geoscience investigations. We need a common understanding of what circular economy means, so I prefer the definition of circular economy used by the Minerals Research Institute of Western Australia, which simply is how business and social opportunities might be found for mine tailings and waste rock. I also propose a central concept. To know what opportunities a mine waste repository might be capable of, first we need to know what mineral it is composed of. And the role of the GSWA should be to acquire and publish that mine site knowledge as pre-competitive geoscience information. So some concrete examples of what might be opportunities. Here are three examples. In the first example, environmentally benign waste can be used to build infrastructure, such as tailing sand for highway construction. In the second example, historical copper and zinc mines may have unrecovered critical minerals that had low economic values at the time of mining, but are now essential inputs for the current high technology economy. And lastly, WA has many millions of tonnes of finely ground ultramafic rocks from nickel mining, which potentially might sequester large volumes of carbon dioxide through carbonation of the silicate minerals left after nickel sulfide extraction. Australian mine waste studies are building momentum. By 2023, the Government of Western Australia had initiated a roadmap to managing decarbonisation of the economy through integrated mineral carbonation, particularly of nickel tailings from operations down Mount Keith, pictured on the right. And Geoscience Australia had announced the Atlas of Australian Mine Waste with a focus on secondary potential for critical minerals and sampling of old mine sites. So consider some numbers. To quantify the scope of work involved, WA has 600 tailings storage facilities that range between 5 hectares and 550 hectares. That equates to about 600 facilities that are as wide as Optus Stadium or up to 10 times wider than Optus Stadium. There are also 2 large dams that cover more than 1,000 hectares. One of those large dams, the 4-kilometre wide Mount Keith Tailings Dam, would cover most of the Perth CBD, represented as the yellow circle on this slide. And by comparison, Optus Stadium is visible just to the east, and its footprint is just a little over 5 hectares. So the volume of mine tailings and the number of mine sites is a material matter for WA. For CO2 capture potential, we have about 2,000 hectares of ultramafic tailings from nickel sulfide mining already, and more mines are on the drawing board. The large numbers involved suggests that data science tools and spatial science tools will be needed to build and maintain spatial intelligence about mine waste opportunities. And a big thank you to Trevor Beardsmore, who recently compiled the Shapes for Mine Wastes in WA. His database underpins the numbers in this slide. So, good geospatial support is going to be needed to query our mine waste data. The first step is to make the logical connection to our digital data between the mine waste repositories and the ore bodies that generated the mine wastes. The Mindex database is one enabler for data matching. The Mindex database is a critical business system in Demers that records data and locations for WA's mines and deposits. The vast majority of Mindex data is in the public domain. Mindex provides geolocated data with robust, unique identifier codes for mining projects and individual features within projects. Mindex data therefore provides one mechanism to match mine waste repositories to open pits by matching the features using project codes. By matching the ore deposit geology to the tailings produced from mining, we can begin modelling the mineral character of the tailings by considering the mineral character of the ore. And this provides one route for answering questions that were not initially considered during the mine planning and production stages. For example, can we quantify the silicate mineralogy of nickel tailings by using the data from exploration drilling through the ore body. So once we've made the logical connections in our data, we can progress to the next stage of a 4D understanding of how tailings dams grow. The two diagrams on this slide represent a hypothetical cross-section through an open pit around an ore body and a cross-section for the corresponding tailings dam. Think of the pit as an ice cream cone shape that gets inverted and then emptied onto the tailings dam. As quarrying progresses deeper through the ore body, the ore is processed and the residues are progressively deposited in the dam. The earliest, shallowest ore forms the deepest part of the tailings. The last mined, deepest ore forms the shallowest part of the tailings, which is the green arrow. So, for example, if the ore body was zoned due to weathering, then we expect that zonation to be reflected in the tailings dam, but inverted. In this scenario, taking samples from the surface of the dam may not capture the significant variations from geochemical processes that affected the shallow part of the ore body. So here's a hypothetical example of the 4D concept for using ore body drilling to predict tailings composition. In this example, we select drill intercepts through the top of the ore body to gain an understanding of the deepest part of the tailings. And the reason for this example is twofold. Firstly, we expect tailings and waste dumps to have internal variation due to the geology of the ore body they were mined from. And secondly, we may not be able to recover knowledge from ore processing in the 70s and 80s, 90s, maybe the early noughties. So we will need to use ore body geological knowledge in conjunction with any post-mining sampling that we may do. So for our progress to date, we've accomplished the following. For mapping, more than 3,500 waste dumps and tailings dams have been digitised in 2D using public domain high-resolution remote sensing. And a big thank you to Trevor. For sampling, 2 sites in southern WA have been investigated in partnership with the MyWatch research team from University of Queensland. And thank you to Steve DePica from GSWA. On the database front, we are planning to support the WA carbonation roadmap with a mine waste database using our updated digitising. Our immediate next steps are convert our 2D maps to 3D so volumes can be matched, which probably requires some innovative use of remote sensing technologies. In partnership with MyWatch, we plan to sample the Ellendale mine site in northern WA. And we have a significant body of work ahead to find mineralogy and assay data within the government agencies that regulate mining and make that accessible through the mine waste database. So in summary, the goal is to build an environment for pre-competitive geoscience to support evidence-based investigation. The environment comprises both database services and data acquisition. The pre-competitive data about mine tailings comes from all stages of the mining cycle. Some from the initial exploration and approval stage, some from the mine production stage, and some from post-mining sampling of wastes. What matters most is that regardless of the stage of the mining cycle that produced the data, we can find and retrieve that data. And that allows us to conduct pre-competitive geoscience investigation of the mining residues. So come talk to us about your project, and thank you.